Mick Grierson is also the keynote speaker of this session, and Mick is a research leader at UAL Creative Computing Institute. His research explores new approaches to make sounds, images, video, and interacting through signal processing, machine learning, and information retrieval techniques. Now let's have Mick. Hello, Mick.
Hi, everyone. Thank you so much for inviting me today. I'm very pleased to be here with you all. I'm going to be talking for about 25 minutes. I'm going to be talking live, and I'll try and make sure that I'm not going to speak too fast so that everyone can have a chance to understand what I'm saying and to give the translators an easier ride. I'm just going to quickly share my screen, and then you should all be able to see what I'm going to be talking about. Okay, so today I want to talk about the ethics of computationally intelligent systems, but specifically in the context of the creative industries. And I think that's useful and interesting to think about because it is currently still very topical. The problems that the ethical problems of AI and machine learning are almost as great as the opportunities. I think that this is something that we've always been aware of, but it's been an issue for us mainly because it hit us very hard when we were beginning the work that we then are now continuing, which many people refer to as creative AI. Creative AI generated immediately a whole range of potentially ethically and legally challenging problems, and we've been trying to deal with those as we have been developing our work. So I'm looking forward to telling you a bit more about those and also to showing you some of the work. So we're going to be thinking about intelligence, creativity, and in what ways AI systems are artificially creative and intelligent. And I'm also, at that same time, I'm going to be talking about text and media generation models. So this slide represents what most people used to think about when they thought about AI. In the West, certainly, this image of the HAL computer from Kubrick's 2001, refusing to do what the person, Dave, was asking them to do. This was a big issue. It was the fear of AI was massive. The idea that we would give birth to some entity which would have control over our lives. The great irony, of course, is twofold, that we already have done this. This has already happened, but not because the AI is refusing to do what we ask, but simply because it can't do what we ask. And so we end up in the same position, but by virtue of bad technology, things just not working. What is interesting, though, in the last few years is that several things which we were finding very difficult, such as particular computer vision tasks and particular machine listening tasks, they have become much easier as a result of a very specific form of machine learning. And this machine learning that we talk about, many of us are now getting very used to the idea that this isn't to do with modeling human activity or human intelligence. It's nothing to do with that, not really. It's statistical, probabilistic, stochastic, and mathematical processes that can be used to learn procedures and perform tasks automatically. And this is nothing to do really with mimicking human intelligence. It's to do with a problem-solving architecture, a way of solving problems using a set of approaches. So recent advances in machine learning, in particular, have been mainly around this concept of deep learning, which I'm going to briefly describe because I think a lot of the time people think that everybody knows what it is, and I just want to kind of provide a very short, quick description of it. So basically, when we talk about deep learning, we're talking about collections of machine learning infrastructure that are layered on top of each other. So we're we have one layer that takes one part of the information, and then that passes what it gets out of the end of that. So it's like a loop. So we go in here with all of our information, we strip off a layer, it goes down to another layer, and we strip off another layer, and each layer looks at a different part of the problem. This is a great model. It's being proposed, actually decades ago. It took an awful long time to get it to work, and it was really because of the work of 2 or 3 fantastic engineers that we started to see it actually do what everybody hoped it would do. It's overtaken traditional learning methods, and it's really had a big impact on speech recognition and on image object recognition. And it's now the case that deep learning systems, even for most of the last decade, can outperform, do better than most humans at certain image object recognition tasks. So here's a kind of a visualization that we put together 5 or 6 years ago, one of my students, Terence Broad, which is an interactive visualization of what we're talking about. So you can see here, what we have is a number of results. These are results. Each one of these different boxes here is supposed to be a number. And this is the decision, the class, which has been estimated by the machine learning system. And it's been trained on what we call the MNIST data set, which is a data set of handwritten digits. And you can see here, this is the input to test the network. And we've put in a 3. And then the first thing it does is it strips off the top layer, the edges, and then it passes that to another layer, and then it gets more blocks. And then we pass all that information through to yet another layer, and we can see these larger patches, the background, the setting. So here we have the subject that's being stripped off. You can think of it like the high frequency information. And then we have the background information. And then we have more of those patches analyzed here. And then it basically says, oh, you know what? I think this one's a 3, 0, 1, 2, 3. That's the brightest activation from this image. It's been trained on these. Let's try another one. So this is happening live. This one, we've put in a 9. We've stripped off the layers, and the system is activating based on what it would normally associate with. We've trained it. We've said, take these digits. This one's a 9. And then we've put a new digit in that it's not seen, handwritten, and it's gone, yeah, here's a 9. But it's doing that by splitting the task into different layers. And then we have these notions of subject and setting spread through the work. And that's basically it. That's how it works, okay? So it's useful to bear that in mind, because we're just talking about a very simple, straightforward process, which has led to the majority of the things that people are very excited about. A lot of people are saying, what about sentience? What about the fact that, are these systems alive? Are these systems aware? What are they aware of? Do we have to treat them the way we treat people? Do they have rights? I think that's a good question, because when we're thinking about who owns things, who the legal owner is, who is responsible for something, let's say your car, your artificially intelligent car, your car, which has, computer vision and machine listening, let's say that there is an accident, who is responsible? Now, you could argue that if the AI is making decisions, that it's responsible. So, is it aware? Is it making decisions? Is it responsible? So I think that there are many different views on this. My particular interest is in focusing on the view of Christoph Koch and others who are like-minded, who wrote a book recently, which is a very easy read, called The Feeling of Life Itself, in which he says that consciousness cannot be computed. Awareness, which we think of as consciousness, awareness, or in some psychological and cognitive terms, working memory, he claims is not computable. And he's the head of the Allen Institute for Brain Science, previously worked with Francis Crick, who discovered the structure of DNA. So an eminent scientist and philosopher, and a very interesting book. So his view is, you just can't compute conscious awareness. It's too complicated given our current mathematical models. Likewise, Jeff Hinton, who created the whole idea, or was one of the people who gave birth to the notion of deep belief networks, which we now think of as deep learning, he has also said that he can't foresee a Terminator scenario. He can't see a time when, these scary AIs just take over and do lots of things of their own accord, but because of their intention to do something. They don't have that intention. And his justification is not quite the same. It's not the same as Christoph Koch's, but it is similar, which is even the biggest current neural networks are hundreds of times smaller than the human brain. That's actually quite an underestimation. It's much more complicated problem than that. But he was asked a difficult question and he gave his answer, which is, he doesn't think that's the issue. There are other issues which are more important than whether these things are aware. And I think that right now we're assuming, and most people who have spent time analyzing them are assuming they are not. So when we think about ethics of computationally intelligent systems, we really don't want to focus on the notion of morals and values necessarily alone. We also want to think about laws and rights, because it's our laws and our rights which enshrine our morals and values, which represent our morals and values. And I want to focus on those things that I think really matter. There are many things that really matter. Some of them I'm not going to talk about, but the ones I am going to talk about are ownership. Who owns a machine learning model? Rights management. Who is the legal creator of a machine learning model? And then finally, can an AI be a creator? Now, I want to talk a bit, before we start getting into the detail, I want to talk about where we are. This website, this jellyfish does not exist. This is a funny website. You go there, it generates a jellyfish from other photographs of jellyfish. And my question here is to do with the idea, is this, what is real? It's about the idea of what is reality. Okay, so let's just think about that. And I think we often forget that all images are merely representations of the world. They are not the world. And in that sense, this jellyfish is as real as any photo of a jellyfish you've seen, unless you're an expert in jellyfish. It's just another jellyfish. Each time you go to the page, you get another jellyfish. None of those jellyfish have ever existed. Likewise, other issues which I think have a greater ethical implication, particularly for in terms of online abuse. I mean, we could say more about that perhaps in the discussion, is this notion of deep fakes. Again, thinking about what is real. This is a famous image of Nick Cage, the Hollywood actor, one of the early viral images that represented the challenges that deep fakes could bring. But you can see that one person being replaced by another, it seems just like a bit of fun, but it's actually not just fun. There are some significant issues to bring to bear. But it's not unusual for art to do this. Collage is a major feature of Dada, Surrealist, Situationist, and related art forms. This self-conscious and deliberate détournement, this notion from the Situationist International, that you would take anything and then transform it for the use of a greater form of art, that is essential to many art movements and now to advertising and marketing. It's a crucial part of our everyday engagement with media, but also has its roots in Dada and Surrealism. These are also, so for example, I'm talking about Tristan Tzara, who stood in the center of Zurich, and legend says pulled sentences out of a hat in order to make poetry. So collage and montage are key techniques also in filmmaking. So around the same time Tristan Tzara was doing that, Eisenstein was talking in Russia about the importance of juxtaposition to create meaning. So all of these are also essential characteristics of generative art. So, famously Lev Manovich would make films that were just random collections of images. And this is based in William Burroughs' work. And not just William Burroughs' work, but William Burroughs famously did the same thing with Anthony Bouch, i.e. the cut-ups and towers open fire. Very often, these art forms are representational, and they use techniques of representation. And as a result, people assume mistakenly that they are somehow representing reality, but they're not. They are distorting and twisting it. Famously, Charles Ridley's 1941 Lambeth Walk, which uses footage from the Second World War, from the German Nazi armed forces in the Second World War, to enact a music hall piece called the Lambeth Walk, which is part of propaganda against the German armed forces in the Second World War. Now, these days, the stakes are very high. New machine learning methods can capture the qualities of representation that we find hard to articulate, that we are aware of implicitly, and we notice when they are missing. So the quality of representation that an AI system can put together, it's not just cutting things together, it merges them together and reproduces them in a way which is very convincing. And it's very hard for an ordinary observer to see that, much harder than simply cutting and pasting. And you can see this famously in materials such as this, which is a Pix2Pix online tool. I imagine this has been around for 6 or 7 years now. It's important because I'm going to talk about this later. Very briefly, this process, you can draw a picture and then you can ask it to make a photoreal version. These days, these systems are much better than this. Likewise, StyleGAN, most of you will have seen this. None of these faces are real faces, but they're made up of what a machine learning model, a GAN, a generative adversarial network, they're made up of what it knows about the human face. Likewise, this image, it never existed. This image is synthesized from a series of other photographs and information. You say, I would like to have these cars here, this road here, these trees, and it will then pastiche it together. So yes, one moment. Yes. So lots of people have tried this in the past. We did similar things back in 2013. We published a paper where we would synthesize new paintings in the style of other artists. And this is called style transfer. And we did this with other methods of collage. We then tried to do it with video. It was extremely difficult to do. And then we decided to try and use deep learning to do that. And we ended up with this Blade Runner auto-encoded, which was the whole of the film Blade Runner, which we don't own, is owned by Warner Brothers, but encoded through an autoencoder. I'm just going to show you a little bit of it now. So this doesn't have the audio on it. Let me just make it larger. I hope you can all see this. So you can see that at the time, this was relatively new. No one had made a whole video of an existing film and attempted to encode it in an autoencoder. And what we found that was interesting about this was that it worked, which was quite astonishing. We had to inject lots of noise into the layers. There was some significant engineering. Generally speaking, people were using a totally different approach. They were trying to do single individual images, and what we were trying to do was create motion and animation. So we had different issues, like how do you deal with frame-to-frame differencing, what in animation we call boiling. Now, we released this onto the internet. My student Terry, who was doing the work in our lab, he made the work 2015, 2016, and put it on the internet. And then within a weekend, it had a large amount of people watching it. I think 250,000 views in the space of a few hours. And then, that caused quite a lot of trouble. And I think hopefully you can see where I'm going with this. So this system was able to reproduce the film Blade Runner and any other film you put into the system without increasing its size. It had aesthetic qualities similar to artworks by artists trying to represent certain similar imagery, right? And so you could make new films. You could do a style transfer of an entire movie. You could put a movie in and then get the same movie out, but it would look like Blade Runner. And so it's low resolution, but it proved the point. And the thing is, it was the first deep learning video to be bought by a major museum as an artwork. And I think it was exhibited at the Whitney Museum, at the Barbican Art Center, Navi in Seoul. And Warner found out about it and said, this is ridiculous. You can't do this. And they issued a takedown and all of the videos online went down. And I remember saying to Terry, look, we should expect this. It's not unusual. It's not our film. And we're using it without permission. And we sent various emails to Warner to say, fair dues, we're academics. This is an academic project. And we appreciate that this is difficult for you. But then Vice, the magazine, did an article on it saying that, Warner takes down the student artwork, because for copyright infringement, when it's actually a really interesting piece of work in its own right. And we got a lot of support from the community, from the art communities and elsewhere. And Warner said, you know what, it's okay. You keep it, it's yours. So that ownership of that work transferred to actually Terence. And that was a big moment, because we were then able to put up the video everywhere, and it could be exhibited and people could continue to see it. But it was a complicated and difficult argument. Similar things happened when we then began working with the artists Massive Attack. And so the idea was, I had this idea, we've got this stuff which can reproduce, we've got code which can reproduce reasonable quality material from existing work and can also be used to recombine it in different ways. So maybe we can remix something. So we remixed some Massive Attack at their request, and this has been on tour. So we remixed the whole of Mezzanine, which is the entire album, and then we finished this in 2017, and it's been on tour for 5 years, and you can only hear it if you go to the exhibition to see it. So it's gone to various different places all over the world, and you can only really hear it if you're there. But I'm going to play you a small excerpt now. I'm just going to skip. Here we go. Here we go. There you go. It's a little quiet, unfortunately. Let me see if I can find another version. One moment. Forgive me. Let's see if it's this one. Here we go. Here we go. So what you can hear there is you can hear the singer and they're singing, and their voice has been reproduced by an AI, and then all of the backgrounds are all generated by an AI. The big problem was that that singer might not want us to make endless versions of that music without them. So we have a model that can make something that sounds like them talking. And at that point, it became quite difficult, because some of the artists on the record wouldn't necessarily want us to make infinite versions of their sound. And that was the challenge. So this made us think about what we were doing lots of different ways. We had to think, well, what kinds of legal agreements do we need to have in place in order to protect artists, right? So this was a big issue. And this isn't the first time this had been encountered. So for example, in the field of music, this stretches back to 1981. David Cope, Experiments in Musical Intelligence, he produced a model that could reproduce versions of Bach, music by Bach and other Baroque composers, without going into a lot of detail. The big question was, is it Bach? And the other question was, is the AI an author? Does the AI own this? So David Cope initially said, yes, the AI has made these, I am not responsible. But then when David Cope, there was a lot of debate about this, but eventually Cope decided that they were his compositions, because Cope had authored the system which produced the compositions. And that's a very interesting and important piece of work. We spent several years exploring this in partnership with Google and Massive Attack. And we did a lot of work with other artists as well, including Ziggle Ross, where we built an authoring system that would allow artists to use AI to make and remix their own works. And this is different because the notion of authorship then lies with that artist. We did a project using software we created called Bronze Format, which allowed Sigur Rós to make a 24-hour version of one of their singles, Route 1. This was watched by 500,000 people when they broadcast it. It was a big media event, and it actually streamed from my phone, interestingly enough. The massive attack work also had a reasonable impact. Lots of people found the work to be compelling and interesting as art. And I think because it's not a direct copy, also the version that you see in the exhibition, it changes all the time. It's not the same. Each time you go, it has a slightly different version. It's producing versions all the time. Now, I want to talk about another technique that we used, which had a big impact, which is this work by Memo Acton, who's another one of our students. They built a system which would allow you to control an existing AI system in real time as an artist to reauthor work interactively. So this is one of the first interactive AI systems that uses deep learning. So it's real-time interaction. And I'm going to show you a little bit of this now, and I'm going to talk about what it's doing whilst I'm showing it to you. Some of you may have seen it, so I apologize if that's the case. So I'm actually, you might be able to hear some music. So I'm just going to sort of talk over the top of it. You can see what we have here is on the right-hand side, a model. That model, what it can do, what it's doing is it's taking images that it's got from the internet, images of the ocean. Now, these images could have come from anywhere, right? So this model, who knows who the photographers are? On the left-hand side, Memo is playing with two feather dusters. And obviously, the system doesn't know anything. It assumes the feather duster on the bottom is ocean, because ocean always goes at the bottom. And then it assumes whatever's at the top is sky, because it only ever knows that sky is on the top. So this gives you an idea of how these systems actually work. And here, this is my favorite part. You place a power adapter here, and this is real-time video feed, right? So it's being controlled in real time. And the system assumes these are rocks, because you don't get power adapters in the ocean. You sometimes get rocks. So this is land. It assumes that's what it is. It tries to make sense of its input. Then if you change it to a different model, such as fire, you can see that now we are in the world of fire. Everything becomes fire. So this allows you to interactively create new artworks on the fly. Now, this uses the pix-to-pix system that I was showing you earlier. What's interesting about this is, who owns this actual model? You know, this model has got information from lots of different people. Loads of different photographers have been involved in producing this model, and they don't know about that. They've not been asked. But it might be that in this case, I know that Memo was very responsible in the way that he gathered data for building this model. But the question remains, that's the important question. You know, why is it that this data is available to you? Is it really yours to use as you please? Similarly, with Stargan, you have a similar issue. Like these are faces of no one, but they're based on the faces of everyone. Like all of the faces that you could find, there are many, many faces which have been used to build these models. But whose are those faces? So I want to consider these issues just briefly in this case study. Now, in 2018, I did a talk largely on similar materials, similar themes as the one I'm just doing now. And at this conference, which is focused on art investment and the art market. And so I was at Sotheby's, which is a big UK art a gallery and a place where people go to buy art in the UK and internationally. And the audience were all lawyers, art fund managers, collectors, and advisors in the market. And I was mainly talking about how generative AI could impact on the art world, and also what the legal and ethical issues might be. The next day after my talk at Christie's, This piece of work by the Obvious Collective was sold for $432,500, which is, 45 times higher than its estimate. And generally speaking, this isn't considered a fantastic piece of AI art, but it is one of the most financially successful. And the issues here are complex because it's certainly the case that many of the people I spoke to the day before were bidding for this artwork the following day. Because suddenly there was this notion that this work might hold value. But even more than that, Robbie Barrett, who is an interesting and exciting researcher who'd done a lot of work on the internet and publicly made that work available, was quite annoyed because he thought this painting was a bad version of something he'd already done. So he said, over a year ago, I did a very similar thing and I put it online. And then this AI generated portrait is now sold for $500,000, but I did all this work and they're using my stuff. You know, they've taken my work and then they've sold it. And I think this is a really interesting set of problems. You know, who is the author in this situation? The issue really is that, Robbie had open sourced all of his work. He'd said, okay, here are my models, here's my artwork, it's all free and open. And Obvious Collective, what they had done is said, great, we'll take that and we'll make work and we'll put it up for sale. But Robbie's output was based also, so in a way you can say to Robbie, look, it's sad that you didn't get any money for this. It's unfortunate for you, but you did make it free. And also your work is based on the work of others. Specifically, his output was based on a large number of paintings by other artists. You know, his code was freely available, but the training set, the data itself came from elsewhere. And I think that's a really interesting issue. It is. And I think it's not one that we can easily ignore. So I want to kind of summarize, given I'm going to skip to a couple of simple case studies to end on. So these notions of creativity and ownership are crucial for the creative industries. So there's a recent Nature article advocating for artificial intelligences as creators. It came out this week and it's here, you can read it. Because many people in the legal profession are now thinking that artificial intelligence, that it's becoming hard to patent things generated by AI, because it's hard to really argue that AIs themselves aren't creators. Now, the big question is, well, surely if you make the algorithm, you own the algorithm. Surely if the data comes from these people, they own that data unless they've given it to you. But this is a part of a lobbying process by people in the industry to allow AIs to be considered creators. And nothing I have seen, and hopefully nothing that I've shown you today, gives the impression that that should be the case. That's my position. Is it really reasonable that we see AIs as inventors? So that's the first thing. The second thing is, it's not a new debate. You know, online internet data is passed around routinely to make models that contain large amounts of, which are based on data that contain large amounts of personal data. Your personal information is used to create models by large companies all the time, and then they relicense those models back to you. This is the same with images. Images are commonly created based on analysis of other artists' work. And you can think of this as a kind of collage, but should the legal situation be different? Also, if you create an AI, is the AI the author of what it creates, or are you? I think rather than being silly ideas, I think these are crucial ideas that we as a creative industry need to address and adopt and consider. And that's the end of my talk.
Thank you, Mick.